All right, so think about this. Every single day, you're sending emails, you're streaming videos, you're connecting with people literally all over the globe, and it all happens with just a single click. But have you ever stopped to wonder what actually happens in that time split second? Well, today we're going to go on that exact journey. We're going to uncover the magic behind how the internet really works. So let's just dive right in.
So, our whole story, it really just begins with a super simple action, something you probably do dozens, maybe even hundreds of times a day without giving it a second thought. And that is, of course, hitting the send button.
I mean, it feels instantaneous, doesn't it? But that one little click, it kicks off this absolutely incredible high-speed chain of events. So the real question is, what is actually going on behind the screen? Now, for starters, your message doesn't just magically appear on the other side. It actually travels. It takes a journey through this vast, pretty much invisible web of interconnected devices that, spans the entire globe. And this incredible system, that's what we call a network. And really, when you get right down to it, that's all a network is. It's just a system that's designed for one main purpose: to let devices connect and communicate with each other. That's it. Whether you're talking about your Wi-Fi at home or the entire global internet, it's all built on this one really simple idea. Okay, so we have these networks all around us, but why are they so indispensable? What is it about these connections that has just so fundamentally changed everything about our world? Let's just try a quick thought experiment here. Imagine you wake up tomorrow and poof, every single network is gone. No internet, no cell service, no credit card machines, nothing. It's kind of a scary thought, right? It just goes to show you how deeply these connections are woven into pretty much every part of our lives. At their heart, networks exist to make things possible. They let us share stuff like printers or files in the cloud. They let us communicate instantly with someone on the other side of the planet. But just as important, they're designed to be incredibly reliable. So if one little part fails, the rest of the system just keeps on chugging. And that design also means the whole thing can scale up. I mean, we can add billions and billions of devices and it doesn't just collapse. All right, now for the really cool part. How does your message actually get from your screen to someone else's? Well, the best way to wrap your head around it is to think of it like a super efficient, incredibly fast, global postal service. See, your message, it doesn't get sent as one big file. Instead, first, it gets chopped up into these tiny little pieces called packets. You can think of it like sending a whole book, one page at a time, in separate envelopes. And second, every single one of those packets gets a digital address stamped on it, telling it exactly where it needs to go. Then, and this is key, devices called routers act like these genius postal workers. They look at each packet's address, and in a flash, they calculate the fastest, least crowded path for it to take at that exact moment. And finally, when all those little pieces arrive at the destination, they get put back together in the perfect order. And here's what's so wild about this. The packets don't all have to take the same path. Just look at this image here. They can take all these different routes to avoid, digital traffic jams, and then they all get perfectly reassembled at the other end. It's amazing. Now, this constant two-way street of information, it has a name. It's called full duplex, and honestly, it's the standard for pretty much everything we do online. Just think about a video call, or even just browsing a website. You're sending and receiving data at the exact same time, constantly. Of course, that's not the only way data can flow. You've also got simplex, which is just a one-way street. Think of a radio broadcast sending information out. And then there's half duplex, which is kind of like a walkie-talkie. You can talk back and forth, but you have to take turns. Over. So this whole system of packets is, it's brilliant, but it led to a massive problem in the early days of the internet. The big question was, how do you get all these different networks built by totally different people to actually talk to each other? Because here's the thing, you had these incredible early networks like ARPANET, but they were basically isolated islands. Each one had its own set of rules, its own protocols. They all spoke different languages. So the dream of a true network of networks, well, it was impossible. The old way of thinking came from the telephone system. It was called circuit switching. And it literally created one single dedicated physical line for every single call. I mean, it was incredibly inefficient. This new way, packet switching, was way more flexible and robust, but it desperately needed a common set of rules to work on a global scale. And this is the hero of our entire story, TCP/IP. The best way to think of it is as the universal translator for the digital world. It's the shared grammar, the shared vocabulary, basically a standard set of rules that all internet-connected devices agree to use. And this breakthrough, it meant that any network, anywhere, could finally connect to and understand any other network. This timeline really puts it all in perspective, doesn't it? You can see the old circuit switching from the telephone days, then ARPANET pops up in the 70s. But look, the real key moment, the turning point, is right there in the 1980s, the creation of TCP/IP. That's the moment that unlocked the potential for everything that came next, the World Wide Web, e-commerce, the internet that we know and use every single day. Okay, so with this universal language now in place, we could finally start building a truly global internet. But that brings up the next big question. How do we make sure it's an internet that we can all actually depend on, day in and day out? Well, it turns out modern networks are built on 4 key pillars. First, there's fault tolerance. That just means if a cable somewhere gets cut, your data doesn't care. It just finds another route, no interruption. Then there's scalability. That's what lets us keep adding billions of new devices without the whole system just crashing. Third is quality of service, or QoS. Think of this as a smart traffic cop that prioritizes your important video call over some background downloads so you don't get all that buffering. It's a huge reason why streaming is so smooth now. And finally, of course, security, which is all about protecting your information as it zips across the globe. And really, that's the end goal, right? All of these design principles, they all come together to create the experience we've come to expect. A network that's incredibly resilient, consistently fast, and fundamentally secure, even with pretty much the entire world connected to it. Ultimately, it all just comes back to this one simple but really powerful idea. The internet is not one single thing. It's a network of networks. It's a massive interconnected web of countless independent networks, all speaking that same universal language, all working together just to connect us. So from just one little click to a global system built on a universal language, it's an absolutely incredible journey. But it also kind of makes you wonder, right? Now that we've built this massive planetary scale connection machine, what new journeys is it going to make possible tomorrow?